Okay, so it's my pleasure to introduce Ken Miller from Penn State. And Ken is going to be talking about converting the Science DMZ that was originally a grant from the NSF into a sustainable service on the Penn State University campus network. So I will turn it over to Ken. As always, if people have questions, either during or after, just put them into chat, and I will make sure that I either stop Ken during or let him know afterwards, and he can answer them. So take it away, Ken.
All right, thanks, Jason. Thanks everyone for joining today. Just kind of a little story about how we've actually tried to transition this from some seed funding into something we can sustain and maintain based on the concepts we've learned and some of the use cases around data transfers, and large data from instruments on campus, as well as data from instruments and other resources off campus. So I have quite a bit of detail on some of these slides, but I'll skip through some of it just so, like I said, if you don't want the details, we can go back, or if you have specific questions, we can go back and drill into it. But I've included a lot of stuff in the slides. Like I said, if we don't go over it today, we just follow up with me, and I'll definitely be in touch and we can work through it. So mostly just talking about why we started this. On our Penn State's an open perimeter network, meaning we don't have border firewalls. We have close to 150 to 200 at the edge. So enterprise and central IT, the networking group serves as like an ISP to the university. So individual colleges, departments, and other campuses contact us, and then we will provide a layer 3 connection or some layer 2 services out to them depending on what they need. So this original grant was brought by our research computing group, or HPC group, but then they asked us to actually go and implement this based on our enterprise network and the fiber we had and things like that around campus. So, but this is our first engagement, really working with researchers directly on some of these use cases. We would get tech calls here and there based on we might have something slow, or something was fast and now it's slow, or but most of the time we really weren't getting too many complaints, and except that people really understood what was going on with TCP, or understood difference about data rates or data transfer speeds. So we looked at some of that, and like I said, if we could do this at an enterprise level, what else could we scale up from there? So we also, at the same time, security being firewalls at the edge, it really just depends on who's running the firewall at the edge. We have vulnerability scanning from an enterprise security group, but firewalls at the edge and where research data is on campus can be in a central location, it can be in a shared location, or it can be literally on someone's desk or a stack of hard drives somewhere. So the use case is really quite abundant once we started looking into this. But like I said, we tried to hit 12 buildings to start, and I'll go through it here a little bit. The network expectations piece, we kind of use it as a baseline. That's from the ESNet site. We just kind of use that to ballpark and try to get a gauge of where people are, what's going on. But through our engagement and just working based on the model that ESNet is doing for the labs, just interviewing some of the researchers, we found people sharing hard drives, walking jump drives across campus, using FedEx, UPS, typical things you're dealing with. One use case, they were flying researchers from our medical center to Chicago to the advanced photon source in Argonne, and flying, hard drives and jump drives and back and forth. And we were just, kind of amazed by that. But like I said, it was one of our use cases. A lot of people have storage on their desk, but we also, and through one of our engagement workshop, or we kind of went over for some faculty staff meetings, and we'd sit in different department meetings and kind of explain what we're trying to do here. And we literally had groups of people carrying hard drives across campus because they were either nested, a few NAT levels deep on the network, or they're going through 2 to 3 firewalls to transfer stuff. It just depends, because some of these labs, they need network connectivity, and that's what they get. And they're happy they're connected, but they're not really looking at performance, and they're just trying to do what they can do to get the research done. So once we start paying attention to some of this and some of the use cases, we could really see what we could do to help them out. This was our first kind of what kickstarted this whole thing. It's a transfer between Penn State and Vanderbilt. We saw these spikes happening in the morning. and throughout the day, and we weren't sure what was going on. And then we started looking at the traffic, the paths between here and Vanderbilt, and we realized this traffic was going over commodity, not over R&E, Internet 2. So throughout the day, we kind of were looking to understand what's going on. The green line is what we're looking at here, and what we're able to see was we were able to take the data transfer from a baseline where it would, it was about the time whenever Netflix and Comcast and Zayo, Cogent, I'm not sure who all was in the bandwidth battles down there in Philadelphia, but we were dealing with congestion across multiple lag ports, dealing with some of these commodity providers, and we would get multiple hops along the way that were just bouncing around. So on the afternoon, we moved over from there to Three Rocks, and then from there we forced it over Internet 2 at Three Rocks, and we started accepting BGP peering. So that alone was the first lesson learned, is make sure you're preferring R&E routes straight away. I know that's commonplace for a lot of people, but we were driven by a lot of bandwidth providers, and we weren't really paying attention to it. So that was really one of our lessons learned. The transfer took around 2 weeks beforehand, then we got it down to about 15 days, or one and a half days. So that was one of our first use cases. We went from there. Again, the CCNE grant, we were awarded that. This was just a, kind of we call it a cartoon diagram of really what our network was. You might go through multiple firewalls across our campus, but our WAN speeds really were affected by edge firewalls as well, because a smaller edge firewall is really not going to let a big transfer through, let alone a border firewall. So we're dealing with small buffer switches, traditionally commodity equipment, really all over the place. And like I said, they go across campus. Every department goes to another department. You might go through 2 firewalls to get there, or a load balancer or something else. So even throughput across campus was suffering quite a bit on some of these use cases. There's a Science DMZ diagram. We went out to RFP for a new core and for our Science DMZ, and Brocade won the bid at 100 gig. We were doing some S-Flow and some SDN with that. And we went with, at the time, we didn't know this, but we went through data center switches using BDX, so cut-through switches, because we wanted 20 gigs out of these 12 locations, 2 by 10, and we were bringing them back to both of our data centers. Well, the one was being built at the time, and so our initial piece was really looking at horizontal data across campus and trying to push 10 gig out to the edge as best we could to get data back and forth to our research computing group. And that's really kind of how we set it up. So we looked at it, when they asked us to do it from an enterprise perspective, we do this, day in and day out, and we kind of look through some of these pieces, and then the opportunity was really to see what we can do to, keep this moving along pretty aggressively, and see what we can do to, work through some of these 12 locations. So this is kind of our ABC diagram, or some people call it the crab diagram on campus, that really is our Science DMZ model turned on the side. We have our border at the top connecting to the world, and we have our core network in the middle that is handed off to our Science DMZ. Since we don't have a border or perimeter firewall, we can, our Science DMZ is actually hanging off our 2 core routers at 2 100 gig lengths. And then off the core is really where the distribution layer happens, is where you have all these edge firewalls in the academic network. So, we have 3 potential data paths to deal with as we're looking into this. And then, what we're going to do to scale this out is really what our struggles were, really dealing with the edge firewalls. So by pulling these 12 locations over into the side under the research area of the Science DMZ is what we're trying to do with this project. This was the original design. This was actually our working design. Talked about the different levels within that. We showed the different tiers and what we're trying to do with the edge aggregation and the core of the network. And here's actually what we came up with at the end. Again, well, these slides will be shared so you can take a look at them all. But we talked about doing this as we actually looked at our switches, and we realized that as we were looking at the data, we were trying to find researchers at one point, and we started looking at the flow data coming from the border, and we actually were able to go out and talk to researchers and say, we see you're sending a lot of data over a long period of time. Is there anything we can do to try to help you out to speed this up? And they were like, kind of amazed that we could figure this out and try to get a little bit faster. So one of the things we learned that I'll touch base a little bit later is it's not just all big data going off campus or on campus. There's also smaller data sets that people are having trouble with. We had a group collaborating between Penn State and social scientists over in Vietnam, and they were trying to use Box and some other sites to get data back and forth. And so we were able to work with them a little bit, even on simple things like that, to try to speed up their data transfers. And I said, the other piece was, what else can we do to take this out where we have a big data area, but also how can we commoditize this so we can take this really to any level of research that can happen across our campus as well as across our state at our 24 branch campuses. We called it kind of a tight on-ramp for the onboarding. It's we call it the kind of the express lane for research. When you go into a city of local lanes and express lanes, we wanted a tight on-ramp, based on some vetting and some security policies and kind of a number of check boxes. But then once we get them on, they can get on and really do whatever they need to do. One use case is we had a microbiology wet lab on campus that was actually working with a sequencer, and they weren't able to get data across campus, and they were literally carrying hard drives or just dealing with the slowness they were getting. And they were actually, they had, a couple $100,000 piece of equipment plugged into, a little Netgear switch that they bought from Best Buy because they needed 2 extra ports. And so that's one of the things we're able to work with them on and install a switch and get the sequencer plugged in. And we actually got the entire wet lab set up on this with 27 work desktops. Can only connected at 1 gig, but before they were only connected at 100 meg. So, little things like that really made a big difference for this entire department. So now they're actually connected at 1 gig for most of the machines, and we're trying to get the workstation now connected at 10 gig at the edge to scale it up even faster. But some of the issues we're running into with instruments like that are sometimes they're maintained by a third-party company, and we can't really do much to, administer any equipment to them or try to upgrade them at all. It has to be part of the original piece. It was already paid for by previous grants. So, but like I said, in either way, we'll deal with what we have and try to get the best performance we can get. This was we were kind of overwhelmed by what we had to do to try to get some of these people on board. And so we actually built a workflow based on new performance aspects, getting an initial connection request, and then once they're connected on the right-hand side of this, we have a performance data transfer, and then we also have if something's down or broken, so a standard, incident response type thing. So we built a workflow in ServiceNow. Everything that was in a dark brown color, if it comes out like that on the slides, but those were pieces built into ServiceNow directly as tasks so that they could actually be kicked off whenever an initiated thing. So initially, it was myself and a handful of people trying to work on this, and we wanted to do what we could with automation and try to see what we could do to streamline this as best as possible, try to get a process built around it so that, we can keep this moving pretty quickly and scale it out. Our basic security presence on this was we deny all traffic by default, so nothing comes into our Science DMZ until we set up ACLs based on the researcher engagement and what the data types they have. So with all traffic denied by default, we talk about what kind of data it is, and we set up a data categorization plan. We work with the local researcher IT support, and security, and do a risk survey depending on how their machines are maintained and how their information's, where it's generated, where it's stored, where it's archived, pieces like that, and understand the risk of the whole thing. The minimum security baseline is something that our security group puts out, and IT support is supposed to be taking care of that. We have a general MOU we can hand out for what is expected on the network. Just because you have a fast connection doesn't mean you need to be watching 4K Netflix or something else. And so we actually limit a lot of that, and we've actually turned on, we usually use just RFC 1918 space on purpose to limit exposure to the outside world. And then if they need to do any external data transfers, use a data transfer node or the HPC facilities to be able to get that data to and from a public site. We have a vulnerability scanning host mitigation. Once our security group's okayed with this, we open up the ports, and then every denied packet that is coming through to that individual IP creates a syslog event, and all these syslogs are sent to security directly. So we just deny all traffic. Everything that is hitting on a deny is sent to security. Everything that is coming through, we're moving to Bro. So we have full packet capture coming through there. And then also every port within the Science DMZ has SFlow coming out of it. So we have SFlow data all the way to the edge, and we can get a number of reports on that. We talked about this thing about the engagement. We really just start out just trying to understand each researcher's story or their workflow. And we started out with really just how much data there is, how much you need to move, where you need to store it, and we kind of just set that as our baseline for our initial meeting or the initial request coming in. And then we really have 2 or 3 meetings after that, 2 half-hour to 45-minute meetings. It usually is what we can do to kind of get through this pretty quickly and get them on board and online. It really just depends on the use case, if there's extra security checks we need to go through, but we try to make it pretty straightforward, and we try to get the right people around the table to start off with and just take care of it. So once we get this base, we actually try to do a history on what they've done before and try to get a baseline of where we're at. Like I said, we look at, from central networking, the other hat that I wear is looking at and monitoring the performance of the academic network, enterprise network. So we actually have the tools to do that. And so our Science DMZ is actually currently more monitored than the rest of our enterprise network based on some of the tools we have and the S-flow from all the edge switches and the big data areas on campus. Then we actually produce a sample report. We do this for a researcher. We actually show what's going on, how much traffic is going to and from their subnets, to their IPs, to their instruments, and actually show them data on really what's going on from there, try to get a baseline and move from there. The next couple slides are really just all the different checks we do as we bring people on board. Talk about the engagement piece, local IT support, the different guidelines we try to produce, the host-based pieces, then the network, talk about that. The onboarding, and we're trying to also stop the opt-out so that, this certain researcher doesn't really comply with this, so they just kind of do their own thing. We're trying to be creative, but as willing to be accommodating as we can to be able to enable this. And security with our deny all and open up only the ports based on the engagement process has really allowed us to kind of custom tailor that. And it can be a little difficult with ACL sometimes, but we're trying to work on other tools to be able to make that more automated as well, whether it be an SDN piece or something. It's just more of a network automation function. And also, we don't allow dual home machines. We do have some dual home storage, but there's no dual home machines on the enterprise or academic network. We just connect them straight in, and then we allow the ACLs to go to the enterprise network if we need to. So when we first kicked this off, we did a peer review with Joe Breen at Utah. And we kicked us off through the CTSC with Von Welsh, and we kind of went through this, and we were kind of both learning because we had initial Science DMZ grants. We're trying to understand what we're able to do with this. So if you have a chance to do a peer review, I'd highly recommend it. It really helped us really kind of realize we weren't really, working through this and on our own. We kind of had some of the similar problems, and then we were able to bounce ideas back and forth. So it actually helped us out quite a bit. Here's just an example of what we're doing with the syslog denies. We dump it into there, and we log all the data, and then it gets kicked into Splunk. We also have another system that dumps it into Elk. So the same data, we can actually do analytics on the packets coming into and out of our Science DMZ. We also are using, we're tapping, like I said, the traffic coming in off our Science DMZ and pushing that back to security. We're looking at a packet broker. They also have a Gigamon as well, and they're dumping that back into Bro right now. Currently, we're going out for a couple more RFPs on some newer equipment and newer software. So I'm not sure where that's going to go in the future, but that's where we're at right now.
So I'm going to pause you just 1 second because I have a related question. What is the time on incident response for something like that? Let's say somebody is knocking on your door, right? How fast does your security team usually act on it?
It's pretty quick. We have a number of pieces where there's been just a handful of things coming in, and they've been taken care of it within 15 minutes to half an hour, where they're blocking things like that. We actually I have later slides in this, a DDoS tool based on this as well. But our typical response is they inject a rule and it is blocked as a border. Otherwise, they have to call our operations center and take the port offline, depending on what it is. So that's really happened on the enterprise and academic network. Since most of our connections here are 1918 space, and they're locked down behind a lot of ACLs, we actually haven't had any security event so far. So that was major anyway. We've had a couple of vulnerability patches we need to take care of, but I actually have a slide on I don't know if it's included here, but I can actually add it afterwards on the incident response times, based on the thresholds on response time and resolution time. We have some SLAs on that I can share with you as well. That's mostly based on network up down, but I think security might have them as well. I can take a look at those. Write that down.
Okay, that answers my question.
All right. Our HPC group was able to get Globus and working with 2FA with a Duo IPAM module, or Duo PAM module, IPAM, different RFP in my mind. But so when we actually use our Globus transfers when we're looking at this for some of these nodes, it actually will kick off a 2FA request from there. And we were able to get that taken care of. So that was actually pretty nice to be able to do. So no matter where you're at using the Globus front end, it'll kick off a Duo two-factor prompt as well. But then we just did some general visualizations, what we could do with the S-flow data on the network. Here we did a real-time weather map. You can click on any one of these links. This is something similar we did at Supercomputing the last 2 years. This was a real-time graph where the host in the middle is actually one of our meteorology servers that data is coming to and from, and just visualizing the traffic in real time. The traffic in blue is actually the host. The traffic in yellow is something from the rest of the university or the academic network. Everything in red is someone from the outside connecting to this server to pull down, I don't know, yesterday's weather. But we can do this really based on a host ID. So it's a crazy screen that just pops around with all these hosts connecting to it. But we did this. We're looking at this for more high-profile connections to see if we can pop anything else up on it, and also correlate that with some of our security tools. This was a flow graph that we looked at, how our traffic was coming in. We built this around the Science DMZ initially, then we scaled it out to the enterprise, and we're looking to push this into production. But it just says really where the traffic's coming from, what AS number, what the second tier is, what border interface is coming in through. The third is what type of traffic, and the fourth is really where it's going on the network, what supernet it's going to. But the two on the far right here, and the purple and the gray, were actually research flows coming in. So you can quickly see, on a wireless taking up quite a bit on the bottom, but the two research flows coming in at the time were pretty substantial compared to the rest of the wireless campus for, up to 50,000 wireless connections. So research flows are quite big at times. So we built a capacity planning model just to kind of look at, what we can do to scale this out and kind of trend this. This is our old RRD model. We have a newer model based on our collection system as well. So we try to be really data oriented around this. We also built something called Border Dash, which is really a broken down of all our BGP peers and traffic coming in based on this information as well. And this is really wrapped, a lot of it around our Science DMZ initially, and then we scaled it out to the enterprise. So things we're learning. So after the grant, the timeline really is here when it was awarded, when we started a working group, when the equipment was ordered, when we talked about the peer review, and then when our initial project ended. And then as we're trying to migrate this into build a sustainability plan for the Science DMZ and what we can do to start building something that is also scaled out. We can scale out based on really any data needs or any data transfer speed you may need. And also extending, like I said, to our campus. The original grant, like I said, 12 buildings. We looked at life cycling the equipment on a 5-year life cycle. We have boilerplate documentation for facilities, areas for future grants. We're trying to meet with our sponsored programs office to get this put directly in there where they can actually put the paragraph about our Science DMZ facilities, as well as select the different connectivity options they can put in future grants based on the pricing they need or the speeds they need, and look at it there. So as line here, not all research computing is HPC, and not all research networking is big data. So we really had to scale out to see what we could do. So we talked about the speeds they needed. They talked about getting data to and from remote storage. And we talked about different things on the research data security, and also if you're getting data for somewhere external, there's probably some sort of compliance or regulation you need to set up with that. So that's something else we're building into the new service model. And we also want to make a governance model around the customers. So we have a governance structure I'll show you in a few slides that talks about it's a combination of researchers and IT support that really has taken a lot of load off what myself and a small group of us are trying to do, because we don't have to come up with all the new features that they want. They can actually tell us and we can build it into it. So we started out with the 4 connectivity models now, but like I said, it's been great because we don't have to try to figure it out. We actually have a voice directly from the customers or the researchers right into what we want to do and what we can provide to them. So this really talks about kind of the business model approach we took for this. The third line down here is really a number we're trying to hammer out, and we're estimating that to sustain our Science DMZ as it is now, based on a 5-year life cycle with purchasing new equipment, is roughly around 80,000 a year. And so out of it's 836 million, I think our research revenues were for last year. So we're looking at 0.01% of the annual research funding to sustain this. So it's just a quick ratio we're trying to look at for this, so we can actually show that what we can do to scale and sustain a Science DMZ is really, not as much as some other equipment may be. But we're trying to find a model where we can work with the VPR, work with our CIO, and possibly work with our security group to kind of figure out some sort of way that if the edge is cost recovered by the researcher directly, what we can do for the core and other components of it, or if there's a higher security level, or if it's really a big data or individual good area where the research may pay for it directly. So yeah, we're trying to hammer that number out, and we're still trying to get our true cost of everything, but we're working on that. The 4 different connectivity types we talked about, we have our original big data area, a 48.1/10 40 gig port switch with 2 10 gig uplinks back to each data center, is around $250 a month. The $60 a month there is really the maintenance of the ongoing switches that were purchased from the original grant. So to keep the continued maintenance on them, it's around $60 a month. Campus fiber is around $20 per leg, so $40 a month. And then individual SFPs are, based on the same 5-year life cycle model. I was told to estimate these and, round up and round, so because I can't actually give out the real numbers, but they're pretty conservative based on what we're looking at. And like I said, I wasn't able to give actual numbers, so I had to round up. So, but like I said, that's about what they are. The second option is if you have a server in a local closet or another on campus that you want to move to the data center in the colo, you can move that in there. So we can give you a 10 gig port in the data center for around $23 a month. So that's a dedicated port, the same speed that an entire college or campus would get, you can get for one individual research machine. So we've been able to scale this out pretty well, and we've actually had people move from other campuses back to here to try to get their data connected at that speed. So the third piece was really how we could scale this out and make a commodity switch using a non-deep buffer switch to get data back and forth across campus. We could look at a 24 or 48 port switch with a 10 gig uplink with 1 gig copper edge ports, so there would be no SFP charge for the edge connections. It's really roughly around $90 a month. So as a researcher comes in, if they want to try to get a dedicated 10 gig for their lab or their research project, it's going to cost them, less than $100 a month for that, just for their lab. So it's a quick way we're trying to entice, new researchers that, or existing researchers that if they want dedicated connectivity, they can get that based on private IP space, based on the onboarding, based on the security model, that they can get their own bandwidth, and we can actually do performance measurements on that to guarantee that bandwidth. So that's really the commodity switch we're looking at. We are looking at a big data deep buffer WAN switch, so that we can look into that. Whereas that's something we're looking into this year to try to go out to RFP on a new switch as well. Number 4 there is a model where a researcher or an IT director was coming to us saying he needed to meet a $200,000, I think it was FISMA or something compliance level, but he was going after a $30,000 grant or something like that. So the economics didn't scale. So we were seeing what else we could do to find a converged model based on, a researcher that only needs a few ports with some security pieces wrapped around it, what we could do for that. And we have a converged compliant port model for like $295 a month based on internal controlled data. If they have restricted data, which is our highest level, there might be more fees to it as we engage security more, but currently it's $295 a month per port. So we have some researchers with it's restricted data that we have air gaps from the rest of the network, and we could turn that around for $295 a port on a converged switch for them and give them it's a dedicated backbone down to that single switch. So here are some of the diagrams. The big data switch really is two 10 gig ports back to each data center. And really this is roughly the model, what it is. We're installing 40 gig back to our HPC group right now. The data center colo server was the second model I talked about. It's really a dedicated 10 gig port. And you can get the server rack in the colo. It's like $23 a month, something like that. So the commodity piece we're looking at is really a 10 gig backbone down to the switch in the middle. And then we can drop different VLANs across that depending on the data types they need, and offer different VPLS instances and different VLANs depending on what the requirements may be. So we can scale this really out pretty far. We have a challenge now where we have some buildings where we have telecom closets that serve the entire building that also would serve multiple customers. So we don't want to install 3 or 4 different switches in there per floor. So in this model, we can run different VLANs over that depending on the data type and scale that out. And that's something we're working on right now, the converged model, or a multi-tenant model. So we don't have to install multiple switches in a building. So we can leverage what we can and then scale it out for the individual researchers. So the compliance port, converged port, is really just plugging into an existing stack of switches. The 10 gig port that's blue and red coming down off the screen there is really the dedicated backbone just for research. But then all we do is pass the VLAN down to the ports they're connecting to, and that's really what the model is. Back across campus, it's using VPLS, on a private instance and a private VLAN to get data back and forth to our Science DMZ. So it allows, for a couple ports here and there, you don't need a big data, you just need something that's compliant or based on something that's air gapped or some other pieces in there. We're trying to work on that. But this is a model we came up with for based on compliance. So we figure if we can build these compliance levels depending on, whether it's NIH data or based on the NIST guidelines or different pieces like that, that we can actually look into scaling this from the enterprise and then offering this out as a service. And we're working with our security group right now and our risk office based on this to keep scaling this out, because like I said, not all data, not all research data is big data. So this is something else we can do to work on that. Like I said, as we're transitioning into service, we're building training matrix around what we're trying to do to try to build up more people like myself, the CI engineer on campus. We've hosted a few workshops. We hosted a Globus workshop just last week, and the OAN virtual, that was on virtual as well. We actually had some people on that. But at the same time, we're also trying to scale out by using traditional equipment and not being extremely specialized. We can see what we can do here to still get the speeds we need, but not train on multiple systems and pieces like that. So we have a staff model here we're looking into. We're actually building like a training matrix on what certain people have been through. These are all the different trainings we've offered since the beginning of the original grant. Talked about the different concepts, what we're trying to do here, like the OIN workshops and the persona workshops you may take here and there, and also the Globus, different pieces we've done there. The governance structure, I'll talk about in a little bit. I have 2 slides on that. It's really taken a lot of load off what we're trying to figure out, and we actually have a voice and a way to engage researchers directly at a committee level as well as an individual level. So, and this actually has a higher level of an advisory council and an executive council above that really is kind of the umbrella between all this. So. Support and operations, all this equipment is being maintained by our central operations center, and all of the equipment is being maintained and monitored by our central networking group. So again, using the traditional equipment, we can actually do this. The same equipment in our Science DMZ is the same in our data center, and the same edge switches we're looking at for our converged and compliant is the same equipment we're going to be deploying anyway. So we're all trained on the same type of equipment. Request fulfillment, we're trying to do as much as we can to automate a lot of this. Initially, it was myself and a guy named Jim. We're trying to work through this as we engage researchers directly to try to get this spun up. We're also trying to create onboarding templates so we can actually get out of the business of the care and feeding 100% on this. So we actually are trying to work on a couple connectivity models and templates so that we can be engaged initially, but we are not actually doing all the busy work part of it and pushing it through the request fulfillment process. We showed the workflow before. The funding model we talked about a minute ago, how we can do the edge pieces. We're working on the core components next. We can individualize every piece of a router down to the port level, so we can actually take that and produce pricing on that as well. We're not sure if that is going to be rolled up as a connector cost, or it's going to be something that is covered by the CIO or the VPR, but we're trying to work on that now. So. Security model we talked about earlier. We build IT management around our service management. So ITSM or ITIL, we actually wrapped a lot of that around it. We have a service owner manager, and I serve as a service engineer for the Science DMZ. And then we also have a business relationship manager that Jim Leos guy I talked about a little bit ago. So we're trying to really build a process around this to keep this thing sustained and running. Marketing communication has really been a struggle. We have a blog that we kind of keep some updates on, but we also are now pushing our pricing and service data to our service website for central networking. So all that will be just like you can buy a standard switch, you can actually buy a research connection the same way. So that's what we're working to do, is try to get it in the streamlined process through request fulfillment. But the marketing piece is what we're working on now. We, like I said in the note here, we just met with the IT communications group and went from there. So the advisory council talks about this, the governance structure. Like I said, there's an advisory council, there's an executive committee, there's a senior advisor that sits on the advisory council, the executive council, and all 7 working groups. So this person really goes to all these pieces to be one central piece. They call him the research guru, but it's really what we're trying to work on. And then here are the individual working groups, the governance being for data centers, data governance, HPC, IT and HR for researcher support, the research network and data classifications really around the Science DMZ governance piece that I was mentioning before, and the software working group. So that's the governance structure around all of research, but Science DMZ is actually nice. It's one component of that. So it definitely has a voice across the enterprise. Some of our opportunities, service roadmap. We have a few things going forward. We have a 4 or 5 year plan right now. We're trying to scale out what we can do depending on use cases that come up. Obviously, speeds are going to get faster and data is going to get bigger, but what else can we do to handle, research networking according to, whatever compliance levels may come out, or different data types or different instruments, or even like, sensor networks that are scaling out with Internet of Things. I mean, how can we create sandboxes or something like that for researchers to work on the Science DMZ? So that's something we're looking at right now. So here's our roadmap. The piece here on knowing our role is really where we can provide visibility to security. We do the S-flow on all the edge switches. We also look at tapping traffic and networks where we can. So we're building out this telemetry model right now. We're using the Science DMZ as an example, and then we can actually take that model and deploy it across the enterprise to get complete traffic visibility for horizontal between department to department, things like that. The other piece here is, try to train and educate for the network as an instrument. I know that's been mentioned in numerous, seminar slides and whatnot, but we're actually trying to explain that to people. And just in a meeting yesterday with a research group, someone actually said that. He goes, we're looking at all these pieces, but we're forgetting about the network. And he goes, the network is a crucial part of this. So that was an IT director that before really just thought the network was a commodity. He actually mentioned that before, and we were brought to the table ahead of time. So it's starting to change a little bit of the culture when I think about storage and compute. There's still the piece that connects the two. So that's something else that has really helped out. And like I said, if we keep going with this, people understand how critical the network can be in research. Talked about interactive sessions. We have a new cryo-TEM microscope being installed, and we're trying to do latency tests to see if we can do remote instrumentation from other campuses across the state, so that we don't have to buy multiple instruments. So we're actually looking at using PerSonar and OAMP to build a consistent latency measure, maybe for remote instrumentation from different areas. So once this microscope is stood up, we're going to see if we can get that scaled out and try to work with them to see if we can, build this as a model we can do for future instruments. Again, our edge firewalls, there's no consistency to it. There is an effort. We have a new CISO now, so there is an effort to put some other security pieces in place and try to be more consistent on firewall delivery so we don't have all these slow edges as we need to. Data transfer applications, sometimes the application is really based on the data set you're looking at and other pieces like that. So it's really there's no guarantee or a magic wand. You say, oh, if you're using this data and this speed, you're going to get this. What about your disk? What about your tuning? What about all these other components? So trying to understand and explain that there's really not like a magic chart we can do, that says you're going to get this type of performance, but we're trying to work on that model. If we can standardize on a few things, then, an FCP across campus versus a Globus or Grid FTP across campus is going to be X versus Y, something like that. So, and again, that ties into part of the outreach program we're working on and speaking to people. We're also trying to see what we can do to build future CI engineers. This is something we've kind of kicked around because, as we get into this, what else can we do on this? So we actually met with our local college and on some of the IST courses we're looking at on how the network can handle both enterprise, cloud, and research applications, how critical it can be to certain pieces. We're looking for, working on trying to get an intern program built in here as well, based on the science D models and researcher engagement, and also trying to work on a possible curriculum to, put some components to that, and then maybe some classes around it, or try to get some, external guest speakers, try to look into something like that, so we can, maybe hire from within and hire some of our students, or be able to take this and scale it out from there. We talked about performance level agreements a little bit ago. We, obviously could build a mad dash graph based on performance, latency, and based on the PRP. They actually have Grid FTP built into the mesh as well, which is actually pretty interesting. It's actually not just a network, but it's actually disk-to-disk transfer. So we're trying to work on what we can do for that type of data around certain data tools. Develop better and cohesive research IT support. This is something our new CIO has been looking at. So if we can build some of this into that ahead of time, some of this, either it's curriculum or just the function of how to troubleshoot, performance problems, we think we can help out. And also we talked about, moving to 40 gig at the edge. For, like I said, our WAN, our meteorology data is, constantly consuming more and more data from wide area traffic. So, and I know some of the new instruments around the world are coming on. Some of our researchers are asking how we can connect. And so we're just trying to keep ahead of the curve on that, go from there. We actually installed a 100 gig PerSonar server last fall to test its supercomputing, just to see how our network could do handling that. And we got to like 42 gigs before Matt from Internet 2 told me to knock it off. But we were able to go from there during supercomputing last year, and we're going to see what we can do again this year. So, and really, it's really kind of the overview. There's a lot of slides after this, but thanks to Jason for always, bouncing crazy ideas off of him. A lot of this modeling was built around the engagement team and the ESNet group, what they've done. Thanks to the seed funding from the NSF really kicked this off, and now, like I said, the actual equipment support ran out, I think this spring or late last fall. So we're actually trying to keep this moving and build a model around how we can keep this going. And like I said, the cost recovery, the edge piece is built. We're trying to work on the core components of it now. Nick, Anita, and Dale worked on a SDN WAN report that actually helped with some of our open perimeter networking problems on the security side of it. And then, like I said, Vaughn Welsh and Joe Breen worked on the trusted CI piece on Science DMZ security and engagement early on. So that's really it. Like I said, there's a lot of performance and other slides after this, like, based on models we looked at and some of the wins we've had. But does anyone have any questions? There's about 15 minutes to go.
So I've received one question so far, and it's from Josh, and it's multi-part, and I really don't want to read it, so I'm going to unmute you, Josh. Let me find you in the list here. All right, Josh, I'm about to unmute you. Okay, go ahead, Josh. if you're there. Yeah, well, maybe Josh walked away. All right, so his questions were, let's see. How are the accounts mapped in Globus? Do you use a centrally provisioned account on all endpoints as well? And are the DTNs the only Globus endpoints? And I'll stop there. There's a couple more questions after that.
Okay. No, so the data transfer nodes, we have a test data transfer node we use for performance testing and really stress testing our storage. But our HPC group has set up a number of data transfer nodes. Some are for certain services, some are just for running Globus on. And the way it is, accounts are mapped to a home directory inside of there. And there's a component for, I forget the other pieces. They have, I think they have kind of a high, medium, and low tiers of storage. The piece was they map to the different directories inside of there depending on what speed of disk they want. So even inside of there, when you log into the Globus page, you can actually see your scratch space, your workspace, and other pieces like that you can move stuff to directly. So it's mapped to directly to the user drive.
Okay, and let's see. Also curious if the Science DMZ is just for the front-end data transfer traffic, or are storage boxes having volumes mounted to compute nodes across this network as well?
No, there are people mounting drives and sharing drives. We have the wet lab I talked about there's a component piece of the HPC group where they have a Samba share running so that the Windows desktops in the wet lab can actually mount. And we have a number of pieces like that. There's also an NFS mount, and then you can actually use Globus to transfer stuff as well. So it's both. And that was one of the reasons for the commodity-based switch, because people were having to go through multiple firewalls or whatnot to go back and forth, and the firewalls are timing out and leaving open and locked files, and it's just been kind of crazy. So.
Okay. So those were Josh's questions. Other people can type questions to me or Ken. I have one while we're waiting for others to come in. I don't think that you put the location of where the onboarding documents live. If those are public, can you send them to me, and I'll make sure that everybody gets a location of that.
Yeah, we're actually reviewing those right now. I try to do an annual security audit to update this stuff, and I'm actually working on that right now. So hopefully we'll have this done by the end of the month and get those there. So I have an idea of the risk survey. We kind of questions as well. It may not be verbatim in what's in there if it's specific to Penn State, but it will give a general idea of what we're asking. And then the MOU as well. And I think on the call last week, UNH talked about a Science DMZ user guide, and I thought that was a great idea. So I started, working on something like that last week. So I thought that was I don't know. See, but yeah, we'll have more of this shared out there as well.
Okay, and then I have, I guess, one more. In terms of just how complex was it for you to really integrate this with your Office of Research? I know a lot of people sometimes have a challenge in basically approaching them and, hat in hand saying, hey, we need some money to run the network. Did you run into a lot of opposition to some of these ideas, or were they actually supportive of trying to help fund out the network for their researchers?
Well, so far the pieces have been really on the edge. Have been billed directly back to the research group, or in that case of the multi-tenant switch for multiple users in a single closet, the facility manager for that college actually is paying for it directly. So the researchers don't have to pay anything for it. So the model behind it's a little interesting. We are trying to meet with the sponsored programs office to try to get something completely formalized, other than just some ideas here. And I think so far the idea, even we presented it yesterday in a meeting, has been kind of taken okay, because I don't think the costs are very high. But again, until it's actually done and I can actually show you something, it's still in the works. But currently the rest of the equipment is maintained by the central networking group, the enterprise network. So we're handling and operating and running, and maintaining the equipment right now. So.
Okay. So Brett wants to know, what does your budget for Science DMZ related activity look like?
Um, Currently, there's the cost of the equipment. There's the one-time cost of the equipment, and then traditionally 5 to 8 years on the maintenance, depending on the equipment. Um, the rest of the pieces are really built around commodity or enterprise components. So they're already set up in a cost recovered, billing model. We're actually transitioning from a um, billing model where you pay a one time and you have just a maintenance fee every month to a standard month-to-month leasing model, or a connectivity model they call it, where the equipment is based on that 5-year life cycle and scaled out. So the components to it right now are the routers and the 2 aggregate switches are the core components. I have all of the individual cards divided up into per unit, like per port. I can do that, but the chassis themselves are what I'm trying to work on now. But for the budget itself, to maintain this from the original grant based on the original equipment, is around 6,000, something like that, a month. So you're looking at, I don't know. I mean, my ballpark early on was like 80 grand a year. So that's really what it's about right now, based on it's a 200 gig network with 40 gig to the edge, or 10 and 40 gig to the edge. And we can do, obviously one as well, but that's really what our budget's built around right now. So, and what they're actually doing for, some of my travel and whatnot, as I go around and understand some of this, they're actually billing some of my travel as not part of training and development, but actually part of the service itself. So some of the times when I travel, it's actually billed back to the Science DMZ budget, not actually to our travel and training budget for, traditional professional development. So I met with a finance person 2 days ago, and I'm actually trying to get hard numbers on that based on what we've actually spent. And, so again, we're at the end of our academic year right now. So we're working on other numbers and metrics like that. So.
Okay. All right. So no other questions have really come in. We'll just stall for a minute or two if anybody else has anything that they want to ask.
Yeah. Well, I'm kind of curious what other people are looking into this. I mean, we have a cost recovered model, and I'm wondering like what other groups may have is, what is centrally funded, what is cost recovered, what is, common good versus individual good. I'd like to go out and talk to different people about that, about how they're handling that on their Science DMZs. A few people I've talked to said, it's just centrally funded and it's done. They don't have to deal with these details. Where being cost recovered, you got to worry about, all these little details. So.
Okay. Well, if anybody wants to type into the chat how you're handling it, that'd be helpful. But otherwise, I think maybe I'll set up a thread on the mailing list and people can kind of respond that way, how they're dealing with it, because I'd be interested too.
Yeah.
All right. Does anybody else have any questions or comments for Ken? All right, I'm not seeing any activity, so thanks so much, Ken, for presenting. Send me your slides, and I'll make sure those get posted into the folder.
Okay.
And I will make sure that the recording gets posted there as well for everybody. And a plug for next week, it's going to be UC Merced. Jeff Weekly is going to be talking about scientific visualization, so a little bit of a change of pace. But hopefully everybody can join for that. And as always, if there's questions, just send them off to the mailing list. Thanks, everybody. Have a good weekend.
All right. Thanks. Bye.